All right, here in this video, we're going to find equations of tangent lines to functions using the derivatives that we calculated in the last video. All right, so we're going to find the equation of the tangent line to root x plus 3 at x equals 1. All right, so when we're finding the equation of a line, we know we want to use this y minus y1 equals m times x minus x1. All right, and they've given us the value for x1 that we're going to use. This is going to be 1. We're going to have to figure out the values for m and the values for y1. All right, so y1, we're just going to find, this is the y coordinate. This is going to be f of 1. So the plain old algebra, just finding a y coordinate for a function. And the slope, we already did the hard work for that. This is going to be, because it's the slope of a tangent line, it's going to be derivative. This is going to be f prime of 1. All right, so let's just plug these things in. I need to figure out f of 1. All right, so I'm going to take my function, and we're going to find f of 1, so root 1 plus 3. We kind of did this by accident when we were finding the limit definition of the derivative. So we have square root of 4, which is 2. So f of 1 is going to be 2. And then we have f prime of 1. Now that was a lot of work. We actually did that in the last video, and we got 1/4. So that was from the last video. All right, and that's the bulk of the work here. Once you've got that derivative from the limit definition of the derivative, finding the equation of the tangent line is not too bad. So I'm just going to plug those two values into my line. All right, so I've got y minus f of 1, which we just found was 2, equals m, which was the derivative, 1/4, times x minus x1, which we said was 1. All right, so let's make that look a little prettier. We're going to distribute this 1/4. And I get y minus 2 equals 1/4 x minus 1/4. And then I'm just going to add 2 to both sides. So I'm going to do plus 2 plus 2. And let's get that to have a common denominator with the 4. So I'm going to multiply this by 4 over 4. And that's plus 8 over 4. All right, so on the left, my 2's drop out. And I've got y equals 1/4 x. Got minus 1/4 plus 8/4, so that's going to be plus 7/4. All right, so that's the equation of my tangent line. And really, after all that work, calculating the derivative in the last video and now finding the equation of the tangent line, it's always very satisfying to hop over to Desmos to graph and make sure it looks like a tangent line. All right, so here we are in Desmos, and I have graphed the square root of x plus 3. And you can see that it goes through the point 1, 2, which is good. That was the y coordinate that we calculated. And let's just graph the equation that we found for the tangent line at x equals 1. So we had a slope of 1/4. So 1/4 x. And then after we worked that all out, we had plus 7 over 4. All right, and that looks perfect right there at 1, 2. It looks like the tangent line. And again, the point of our tangent line is so that we can zoom in on this function and we cannot even tell the difference right there at x equals 1 between our tangent line and our original function. All right, so here's the other function that we found a derivative for in the last video, f of x equals 4 over x minus 5 at x equals 3, and we'll find the equation of the tangent line. So again, let's write down our y minus y1 equals m times x minus x1. And again, the x1 they gave us, that's our value of 3. We'll find the y1 by evaluating the function at that x coordinate, so f of 3. And then we know that the slope, because this is a tangent line, is going to be f prime of 3. All right, so f of 3, we again did this in the last video, but we'll just do this one real quick. F of 3, we plug in 4 over 3 minus 5. It's 4 over negative 2, which gives us negative 2. And f prime of 3, again, we know this is a ton of work. Again, I did this in the last video, so we're just going to copy our answer down. F prime of 3 we got to be equal to negative 1 in the last video. All right, so let's plug those things into our equation. We've got y minus f of 3, which is negative 2. So what's going to be y minus a negative 2 is y plus 2. Our f prime of 3 that we got was negative 1. And then we've got x minus 3, no fractions this time. This is an easier tangent line. So I've got y plus 2. Let's distribute our negative 1. And I get negative x plus 3. And we'll subtract 2 from both sides. And I get y equals negative x plus 1. And again, there's no way I'm going to do all that work and not graph it just to make sure that it looks right. All right, here we are in Desmos. I have graphed 4 over x minus 5, and it goes through the point 3 comma negative 2. That was the point that we found when we were calculating f of 3. So that's so far so good. Let's plug in our tangent line. We found y equals negative x plus 1. All right, and that looks perfect right there at 3 comma negative 2. The line comes up and just touches the graph, and it's perfectly tangent. We can zoom in and we see that is a perfect approximation right there at 3 negative 2. All right, that's it for the videos today. We'll do more when we get together in class again.